Hey there guys, it is Vizonex, and today I wanted to show you all a project I've been working on for several months that I haven't released to GitHub yet because it's so special to me currently and I have no good names for it yet. But I wanted to sort of give my reasons to why I made this library and what inspired me to go ahead and put this together. So, first of all, there are no proper DSLs to create, powerful C parsers in Python. Now, it does exist for TypeScript, and that name is llparse. But I really wanted, this crazy functionality to exist in Python. And my inspiration came about how I discovered this library was that I was reverse engineering some of aiohttp. I wanted to sort of learn, how everything works, and that's how I, was able to discover why this library was so fast, and you know, and that was sort of how I started, looking for, libraries that could do what I wanted. I did stumble upon a library called No Memory for You, but the problem with this library is that you're not actually writing Python code. You're writing someone else's language to build C code, which is not what I wanted to do. I wanted to write Python to build C code. So that's sort of what I have done. And allow me to demonstrate with this parser. And let's call it Vizonex right now. And what I'm going to do with this is I'm going to sort of, demonstrate to you how this sort of works. It's very similar to llparse, but it has a few tweaks here and there, such as a flag called switch case that you can put together, and you can give it a subroutine name. And in this case, I'm going to call it E, for instance, or I can also do a lookup table, which might actually be a little bit better if you're trying to do a much stricter algorithm. So, and in this case, we can map numbers to different letters. So, like, I could have it mapped to all the possible numbers of 0 to 9. And let me give it a key. Now, I did map 0 to default, so that's why there is no 0. And then maybe if we like hit a colon, for instance, we could map that to somewhere else. So then when I say, on delimiter, I could have it mapped to 1 and then have it go to somewhere. Now you might be wondering what this error thing up here is. So let me import the error wrapper. It's actually just an enum, or a bunch of flags, if you will. And I can use that to sort of, build out errors. So like, let's just say we have a class called error, and then we create an error wrapper around it. And then let's just say, for instance, that we want to wrap some really interesting stuff to it. So what I could do actually is do this and say at parser dot at p dot errors, or error enum. Or actually no, that's the one to wrap the a thing to the object. No, it's actually going to be let me find it really fast for you. Oh yeah, it's called errors. I don't know why I had this uppercased, but yeah, it's not errors. Yeah, it's not that. Give me a sec. Okay, so I did find the wrapper. It's called main errors. My bad. And let's just say, for instance, that this enum. Let me just block my caps. We could just say this is a malformed key, like that, and then we could say error enum, and then we can give it a message. And what this tuple is going to do is make sure that it actually gets mapped properly and doesn't overwrite, if you will. And I've had this annoying functionality with enums, so that's why you're seeing a really large tuple right here. And I really wanted to make sure too that this thing had a heck load of documentation. So that's also what I did. So I could say, for instance, error malformed key. Something like that, or no, not signed, unsigned. There we go. So, yeah, that's sort of, the idea. So if I call on delimiter for this lookup table right over here, what I could then do is sort of map back to where I want it to go. And I could also invoke a function or an event. And this will allow me to parse everything in C in chunks. And I have a way to, sort of go about this as well that you're going to see pretty soon. But first, let me call on delimiter. And with that, we're on 1. And what I can do is I can just have it call back to key, but then on, or no, not on, by default, raise error by default, and then I can map it back to error dot malformed key. And what I could also do here is I could have it map to the second object, which is on delimiter 2, and I could have it go straight to another sequence, such as instead of key, I could have it map to value, and then I could say I could invoke a function called onKey, which will basically load us up our chunks just like how llhttp works, and that's pretty awesome. So that's sort of how it works. Let me map it for you guys and compile it so I could show you what exactly it has made me. So first, let me tie this to its name, its subroutine name, and then I'll print out and compile this part for you so that you can sort of see what I'm building. You'll be able to see some of the C code that I've put together. I think I mapped these the wrong way. Give me a sec. I remember having to change some of the mapping just so that some different functionality would end up working. So I will definitely have to add some error checking in the future to prevent some of this from occurring. But there we go. There's our look at the C code that we put together, and this is the setup for a lookup table, so that we only get numbers back instead of errors. So it will go to our very first error that we put together. That's why this subroutine's right here, and then it will call the function. It will reset the position, and then it will go to SNLL Vizonex value, which is a state in the parser. Something else that we could do too to actually load it in chunks is called on end of file, and then we could also invoke here on key as well. But to flag that it's been finished, we could call an event right here called onKey finish or complete. And now when we hit an EOF or end of file, we can load everything into chunks, as I will demonstrate. And that's sort of the concept. We are sort of building our own C library. And I actually would have been fine with writing a bunch of C, but the problem with that was just the pure amount of slowness involved. And I didn't want something that was, going to be a painful process, and I wanted something that was going to be interchangeable, just like how llparse works on its own 2 feet. So we can append states, and let me append key. And now let's create a second subroutine called value. So let me create it with just a simplistic switch case. And this one's a lot simpler than a lookup table. But now we can append its case. Or no, not append case, it's on the limiter. And then when another colon appears, we can simply just go to we can loop map back to key. We could call finish, etc. I'll have it map back to key for now. And then I will write another thing to signal that yes, it's finished. You're done. And maybe that would be the 0 delimiter, for instance. So let me add in or chain another value on delimiter. And then we could call over here, we could say that go to parser finished, for instance. And that's sort of my concept. And then once we have mapped all that out, including our final delimiter, let's also make sure that it gets the last chunk, for instance. This is a pretty bad parser, but this is purely to demonstrate what I've done here. Now, normally you would just map this to the actual value. So you know what? I'll do that. Let me make this into a true library for you. Quit rambling. I'll be back to write more of this in, so you don't have to hear me ramble. And really fast too, I wanted to show you guys a little Easter egg I added, which was the select function. And what a select function does or is it's similar to how llparse actually works, where you take in a selection of different things that you want, and you put them all together. And you basically can do this to create multiple different matches. You can do this, create a bunch of matches, and call a bunch of different stuff. And part of the reason why I made this too was that I had another private library that I was putting together, and I wanted it to check for Cloudflare errors and stuff, which is why I actually went ahead and made a gist on GitHub that is full of Cloudflare enum flags that can be used. And I created a tiny little checker for those that wanted to, check to see which flag they hit. So, yeah, pretty useful. Wanted to give a little nod to that. So, let's just say, for example, we wanted to match Cloudflare up. We could do a Cloudflare match sort of thing. And then we could create our very large selection of stuff. This time I think I mapped it correctly. Yeah, I did. Type hinting's good. Let me check this one. Type hinting is not good. Let me fix this really fast. And as you can see, I went through a lot of iterations. And I actually had a previous library too that did this, and I rewrote it to be a bunch of files instead of just one, to be a little more organized than I was about, portability. And I really wanted to, be pretty specific about, some of the things that it does. It's not the same as llparse, but it is pretty close, and this is where the inspiration came from. And I wanted the settings to instead be baked into the project instead of just be outside and have to do a bunch of sneaky stuff to get everything in there. So I really wanted compatibility on top of that. So, for instance, let's just say we have error 1015, which is rate limit, or we have error 1020, which is I believe it's something to have to do with forbidden, if I remember correctly. So let's say we wanted to match out, some of this stuff. What my tool will do is it's going to build a tree, and then that tree is going to be used to assist in building all the switches and making everything look nice. So, yeah, let's make a preview for this one, just for you guys. Dot compile, so that you can see all of the amazing work I've done. Here we go. This is really cool, actually. Please work. Okay, something is wrong. Wait, did I map this correctly? Oh my gosh. I think I messed up my keys. Hold on. I think I type hinted this wrong. This is embarrassing. Oh, I don't have any delimiters. That's the problem. Okay. So this time it's actually called onMatch. And what onMatch is going to do is we can have it mapped to a specific error that we can throw. So, like, for instance, we have a Cloudflare error called rate limit. We can then say to the error enum that, let me get rid of this so I can see this better. Then we could say to this, Cloudflare error. Or actually, you know what? Let's just call it rate limit hit. That's better. There we go. So I said, server asks that you back off from making requests for a bit and slow down the request rate. So that's one of them mapped. And then the other one can be CF forbidden. And then with this one, I can say forbidden. Site does not like proxy usage. So it's like those sorts of things that I can call. and that's pretty amazing. So if we were to hit this match, we could have it go straight to error dot Cloudflare forbidden, and then on this match right over here, we could have it call the other thing, which is going to be basically on its match, which is number 2. We can have it call error. Yeah, it's not CF forbidden for this one. It's CF rate limit. We could have it mapped to error CF forbidden, and that's sort of how this all pans out. And then on default, we could have it mapped to we could have it go to key, for instance. Since the check was made, it passed. Just skip and continue. So that's sort of how it works. Now let me compile the preview of this code specifically. Mainly just the match. I did not compile this. Hold on. There we go. Now we should get the C code. And there we go. There's our generated C code. These matches are a little out of order, but I actually developed a workaround for this. And that was that there's a time pref counter of nanoseconds. And that is going to help me reorganize the way everything was created. So just a little nod to that. And yeah, that's sort of how my tool works. Let's actually go ahead and try to, compile this into, C. It's not a full parser because it doesn't have a finish flag. But this is sort of how you would go about, finishing and whatnot. Actually, I think I have a thing called a return. Yeah, go to is return. That's what it's called. Go to is return, and I can just set this one to true. And then there we go. We are basically done. And I can compile this for you and show you all of its juicy C code that it's going to build for me. I also gave it, as you can see over here, I am developing a Cython builder, which will be pretty unique for bridging stuff over to Cython, because one of the things I really hate is that it lacks type hinting. It lacks a proper Pylance backbone. Like, you can't just hover your mouse over something and see the documentation. You actually have to go in and pull it out and read it. It gets pretty annoying. So that was one of the reasons why I'm developing a Cython builder as well, to bridge the project over. So, yeah, that's sort of how this all works. Let's do the final part of putting all this together. Let me append the last, state. You can also put in multiple nodes, and there's actually multiple things, like there's a flag switch, there's a start flag, and there's a switch case. I showed you 3 of them. And yeah, let me put in this last append states object, and then we'll pass this thing off to the compiler pieces, to C compiler. And if we were to pull out the main struct, we could manipulate some of its own objects to be invoked. But I'm not going to do that here. It's still going to build the main struct. It's just, if you were to pull it out, you have to put it back into the compiler. So that's why I did that. So let me make this into C compiler. And then you're going to see the generative code that it makes. Let me actually figure this out. Thing I was supposed to call. I think it was. Hold on, give me a second. I kind of forgot what I was doing. Okay, so I sort of solved the problem, and what I'm going to do here is that this is our start, which will be checking for Cloudflare errors, and then when we append our states, we're going to call that same start flag, and then we're going to compile the starting state action, which is this, and we're also going to compile. So 2C compiler is really just the part that's going to build all the headers, and then it's going to send you off to the compiled C code to then write to your header file and your C code. So that's sort of what I did here. So do we want to sort by name? No, we want to sort it by the way it was built. And then pick up first is basically don't check if the object is null, just take it. And then if we had any extra things that we wanted to add to it, or any of that like specialized enums or anything, and wanted to inject into our header file, we could add that right here. And that's sort of how it works. So then, yeah, let's take this. We'll call this compiled, and now we'll build its files out. And let's make a directory for this. And now let us build our files. All right, let's do it. I'm excited. This was a really fun project to work on. Uh-oh. What did I forget? String has no attribute sname. I called it sname because it's similar to subroutine name. Let me see. What did I do wrong? What did I do wrong? Oh, I called compile. That was why. Okay. And it thought that was a string, so it didn't know where its attribute was. You gotta be careful with these sorts of things. What now? I gave it a multi-match. I appended its states. What is this? Crap. I actually figured this out. This is so dumb. I appended the state right here, which called start, which... this is what happens when you're, not thinking straight. And then... what else? What else was my problem? Tuple index out of range. How is this out of range? Wait, what? Like, I thought I gave it this. That is so weird. Wait, let me check. I don't think a certain part of my code actually works yet. And I think that part is Yeah, there is no extras. So therefore it is trying to throw me an error where there is no extras. So, yeah, let me go in and fix this, actually. Is there another way to check for this? Is there another way for me to check that, this actually was, existent? Here, I have an idea. Let's diagnose the error of extras, and maybe we'll see where, I went wrong. Okay, that is where I went wrong. Okay, so if extras... Let's print out its type, actually, so I can figure this out. Maybe if this is equal to none. Is equal to blank. Okay. Okay, thank you. There we go. I think I've made a better check for this part now. So that's good. Let's do that. Wait, not equal to. There we go. And there we go. I fixed it. Congratulations me. I have successfully made a C library. And as you can see right here, we have it built. There are a couple of errors, like I said, or like I'm going to tell you right now that my project is still in beta, like it's being tested. You know what? Instead of calling null right there, let's just give it its representation of 0, so that it's not calling a null, which might be a problem. But there's its errors. Yeah, I think it's the null value. Let me fix that for you really quickly. That's what's there, because there's supposed to be no errors. It's supposed to compile correctly. So let me fix this. I'll give it its representation of 0. I was smart about this. I did allow for a union to pass. And someone is texting me. Okay, back to what I was doing. Let me do this with the new fixed delimiter. And there we go. Problem solved. As we can see, everything maps out correctly. This is a proper parser. And as you can see, it is pretty different to the way that llhttp is set up. Like, it's not the same. I wanted the macros to instead be called straight from the main function to make the library a little more compact. As I didn't want to have to call, 3 billion different things at one time to get it to compile. I just did not feel like that was, completely necessary. But here's all of our, flags. And if we head over to the header file, you will see that I've created the functions that it can call and all of that other good stuff. So that was it for my sort of, look at my project. I will give this thing a test run in a future video. So stay tuned for that. Be sure to like, share, and subscribe. Maybe I'll throw this library onto GitHub at some point if you guys really really want me to, and give you a more extensive documentation. Anyways, that is it. I love you all. Please subscribe. I will see you on the next video.